Hello, and welcome to the Connecting to Your PLC and I/O Module Setup. This is Session 2 of the Programmable Logic Controller, PLC, and ControlLogix Fundamentals and Troubleshooting series. This presentation has been brought to you by Flux Automation Services, LLC, and the Non-Ferrous Founders Society. In this series, we will be discussing the fundamentals of PLCs using the Allen Bradley ControlLogix platform for our demonstrations. These brief sessions are intended for entry-level individuals that may be intimidated or interested in PLCs and/or automation. Our goal is to provide basic knowledge and break down these systems into easy-to-understand segments to wane fears. First, a little bit about myself and Flux Automation. My name is Dan Horvath. I'll be your presenter for today and the remainder of this series. I have over 20 years of controls and automation experience in various industries and several years of foundry experience. Flux Automation Services provides a complete list of automation and integration services, including but not limited to PLC programming services, control panel design and fabrication, control system upgrades, industrial servers and networking, system assessments, anytime emergency services, and control system consulting and consultation. For a complete list of our services, please visit our website at www.fluxautomation.com. Flux Automation aims to simplify technical information to educate industrial clients about their control systems, fostering their comfort and understanding. The information provided in this session is intended for reference purposes only. Agenda. During today's session, we will be covering the following topics. First, a Session 1 recap. Second, Ethernet connection, where we will be connecting the PLC to your workstation via Ethernet connection. Third, BOOTP-DHCP software tool. We will be using this software tool to assign the network module and IP address. Fourth, using RSLinx Software, where we will be adding our PLC communication path and assigning a static IP address to the communication module. Fifth, using ControlFLASH Software to flash the desired firmware version to the PLC processor. Sixth, using RSLogix 5000 software, where we will create a project, add I/O modules, download the project, and go online. Finally, we will be wrapping this up with a live Q&A session. This presentation has been pre-recorded, so please save your questions for the live Q&A session at the end. Session 1 recap. In our previous Session 1, hardware introduction and visual troubleshooting, where we discussed ControlLogix hardware and how to visually troubleshoot your PLC system by reviewing the status indicators. During that session, we assembled a ControlLogix PLC rack, and now we are ready to connect to it. If you have not viewed Session 1, I recommend watching that video before participating in this session. Ethernet connection. Allen Bradley ControlLogix equipment utilizes Ethernet IP, Industrial Protocol, is a communication protocol used in industrial automation applications to enable data exchange between devices and controllers on an Ethernet network. It is an application layer protocol that uses standard Ethernet hardware and infrastructure, making it easy to integrate with existing Ethernet networks commonly used in office and industrial environments. Ethernet IP is one of several protocols established under the Common Industrial Protocol, CIP, umbrella, which is managed by the Open DeviceNet Vendors Association, ODVA. The CIP suite includes other protocols like DeviceNet and ControlNet, each serving specific application scenarios, while Ethernet IP is designed to work on standard TCP/IP networks. Next, I will be showing you how to physically connect your PLC processor to your workstation. Here is an example of the easiest way to connect to your PLC processor. Here is a PLC rack with the Ethernet processor, network communication card, 2 DC input modules, and 1 DC output module. As you can see, when you receive your network communication card from the manufacturer, it is set in boot P mode with the MAC address scrolling. Please note this MAC address as we will be using it later. As you can see, this is connected with a standard Ethernet cable from the PLC network module over to my laptop or engineering workstation. My laptop does not have a built-in Ethernet module, so I'm using this simple USB network module I received from Amazon. Note that it's typical with any modern network module that they will auto-negotiate to a crossover scenario when directly plugged in to a device. Now that we're physically connected to the PLC, we can logically connect through the software. The BOOTP-DHCP tool is a network protocol utility used for managing and assigning IP addresses to devices on a network. BOOTP is an older network protocol that was primarily designed to help workstations obtain their network configuration information during the boot process, where a BOOTP server maintains a database of IP addresses and corresponding configuration information such as subnet mask, default gateway, and DNS server addresses. When a device client starts up and broadcasts a BOOTP request, the server responds with the necessary configuration details, allowing the client to join the network. DHCP, Dynamic Host Configuration Protocol. DHCP is an enhanced version of BOOTP that provides more advanced features and flexibility in IP address management. It offers dynamic allocation of IP addresses, meaning devices can obtain temporary leases on addresses rather than being assigned a fixed address permanently. DHCP also supports automatic renewal and release of IP leases, reducing the administrative overhead of managing IP addresses manually. Next, I will be showing you the steps to first change your local network IP address to a static local address, and then we will be changing the network module's BOOTP mode to an assigned static network address. Once you are physically connected to your PLC processor, you want to go ahead and get access. First thing you're going to want to do is go to your network configuration. Now in this image I am running Windows 7, older version of Windows, so your Windows layout will look different. I'm going to go to your network configuration settings, your network adapter, your Internet Protocol version 4, TCP/IP v4, and make sure that you have your network address set to a static IP address. Now, if your PLC processor is already established on a current network, you want to make sure that this network address does not conflict with anything else that's on the current network. Here I've just selected a local IP address, very simple, 192.168.1.100, and the following subnet mask. So we're going to go ahead and OK that. Now we must assign an IP address to the PLC network module that is currently in the BOOTP mode. So we're going to go ahead and bring up our BOOTP-DHCP tool. It's going to ask us which network we want to connect to. Then it'll bring up whomever on the network is requesting an address. As you can see, this MAC address matches our PLC network card with it requesting an IP address. We're going to go ahead and double click on that, and then we're going to give it an IP address. I'm just going to make it 192.168.1.10. We're going to press OK. Now it has popped up down here in the assigned portion of the devices. You can go ahead and click Disable BOOTP. Now that the IP address has been assigned to the network module, we're going to go ahead and verify that by trying to ping that IP address. I'm going to go ahead and go to our command prompt. We're going to type ping, P-I-N-G, 192.168.1.10. And we successfully have a reply. In the next steps, we'll be showing you how to use RSLinx to permanently make this configuration. RSLinx Classic Software. RSLinx is a software communication driver developed by Rockwell Automation. Key features include device connectivity, data access, configuration and setup, advanced diagnostics, OPC server functionality. Today we'll be focusing on configurations and setup. RSLinx provides a user-friendly interface for configuration communication settings and establishing communications to devices. It allows users to define communication paths, set up communication drivers, specify device addresses, and manage network configurations. This flexibility enables users to adapt RSLinx to various network environments and device configurations. Next, I will be using RSLinx to show you how to configure a path for a device, browse the PLC backplane, and permanently set our IP address to our network module. After installation, and once the service is running, you'll find an icon for RSLinx down in your task tray. Right-click on it, click Restore to open the user interface. First thing you must do is configure a driver. Click Configure Drivers button, select the drop-down menu, and select Ethernet devices. Click Add New. Go ahead and stay with the default name or rename as you see fit. Here, we're going to add the host IP address of the PLC processor or network module we want to connect to. So if you remember from before, it's 192.168.1.10. And we're going to click Add New. Apply. Okay. Now our new driver is running. Go ahead and close out of that. Now we are going to click this button that says RSWho. Under here, we'll find our new driver, and it is browsing. And it does say node found. Click Expand. Here is our network module. Under our network module, we see our 10-slot chassis. And then under our 10-slot chassis, we see our Logix processor, our network module, our 2 DC input modules, and 1 DC output module. To make our IP address final, we'll have to right-click on our network module, select Module Configuration, Port Configuration. Here you can still see that it's set in dynamic. We want to set this module to static IP address with our IP address set as before. The Use BOOTP is now grayed out. We'll keep it on auto negotiation for the speed and duplex. Go ahead and hit Apply for that and OK. Now our network module is fully configured and will retain the address through a power cycle. ControlFLASH is a software tool developed by Rockwell Automation. ControlFLASH provides a straightforward and streamless process for upgrading the firmware of Rockwell Automation devices, ensuring they have the latest software enhancements, bug fixes, and feature updates. Firmware updates are important for maintaining device performance, reliability, and security. Key features and functionalities of ControlFLASH include firmware compatibility. ControlFLASH supports a wide range of Rockwell Automation devices, including PLCs, motor control devices, industrial communication modules, and other control products. It ensures compatibility between the software tool and the devices it is intended to update. Firmware management. ControlFLASH provides a centralized platform for managing firmware files. It allows users to import, organize, and store firmware files associated with different devices. This helps to keep track of available firmware versions and simplifies the process of selecting and applying updates. Firmware update process. The tool guides the users through the firmware update process with a step-by-step interface, and ensures the appropriate firmware file is selected for the target device and verifies compatibility before initiating the update. ControlFLASH communicates with the device and transfers the new firmware and verifies successful completion of the update process. Version control and rollback. ControlFLASH enables users to manage firmware versions effectively. It allows users to select firmware versions for installation, ensuring the devices are updated with the desired software. In cases where an update causes issues, ControlFLASH may support rollback to a previous firmware version to restore device functionality. Overall, ControlFLASH simplifies the process of updating firmware for Rockwell Automation devices, providing a user-friendly interface and robust functionality for managing firmware files, applying updates, and maintaining device performances. By keeping devices up to date with the latest firmware, ControlFLASH contributes to the overall reliability and security of industrial control systems.
Next, we will be using ControlFLASH to identify and to update the firmware version of our PLC processor. Through RSLinx, we can see on the properties page of the PLC processor that its current revision is 20.018. Now, if you wish to update the revision of your PLC processor, you may do so through ControlFLASH. Unfortunately, this is one of the higher revisions for this older processor. So unfortunately, we're just going to keep it at that revision. But anyways, I will show you the steps to do a ControlFLASH flash of your PLC processor. Start by opening the ControlFLASH program. Click Next. Select the model of the processor you wish to update. In my case, it's 1756 L63. Click Next. Within your path that you've configured before in RSLinx, drill down to the selected PLC processor. Once you have your processor selected, press OK. Here, you can see the revisions that we have to choose from, or you can show all revisions to show older revisions. I'm going to go ahead and stay with 20.018. Click Next. Read the disclaimer warning. Click Finished. It'll ask you, are you sure you want to begin updating the target device? Click Yes. As you can see, the target device will update from its current revision to its new revision. Once the transfer is complete, the PLC processor will restart and the software will wait for a power-up. On completion, you'll have a status update complete with the new firmware. Click OK. Now here, to close out of the application, just click Cancel and Yes. Now that we're connected to our PLC processor and updated it to a new firmware, we are ready to set up our RSLogix 5000 program.
RSLogix 5000, now known as Studio 5000, is a software platform developed by Rockwell Automation, a leading provider of industrial automation solutions. This software is used for programming and configuring the Allen Bradley Logix 5000 family of programmable automation controllers, PAC, including ControlLogix, CompactLogix, and SoftLogix. RSLogix 5000 provides a comprehensive set of tools and features for developing, testing, and maintaining industrial control applications. It offers a user-friendly interface and a wide range of programming capabilities, enabling users to create and customize automation programs to meet their application requirements. Key features and functionalities of RSLogix 5000 include the Integrated Development Environment, IDE. RSLogix 5000 provides a unified development environment for programming and configuring tasks. The IDE includes tools for creating and editing ladder logic, structured text, function block diagrams, and sequential function charts. It offers a familiar programming interface for PLC programmers and engineers. Tagged-based programming. RSLogix 5000 adopts a tagged-based programming approach, allowing users to define and manage variables, tags, within the application. Tags represent input-output signals, memory locations, and other data used in the control program. The tagged-based system simplifies program organization, enhances readability, and enables effective program reuse. Online and offline programming. RSLogix 5000 supports both online and offline programming modes. In offline mode, user can develop and test programs without being connected to a physical hardware. Online mode allows real-time monitoring, debugging, and modification of running programs on a target controller. This flexibility enhances productivity and simplifies troubleshooting processes. Advanced instruction set. RSLogix 5000 provides a rich set of predefined instructions such as mathematical operations, logical functions, timers, counters, and data manipulations. It also supports user-defined function blocks, allowing users to create custom instructions and reusable code modules to streamline programming tasks. Diagnostics and debugging tools. RSLogix 5000 offers powerful diagnostics and debugging tools to assist with program analysis and troubleshooting. It includes features like online cross-reference, force and monitoring of tags, rung highlighting, and online editing capabilities. These tools help identify and resolve errors and ensuring optimal program performance. Integration with other Rockwell automation tools. RSLogix 5000 seamlessly integrates with other Rockwell automation software tools such as RSLinx, as described earlier, for communication setup, and FactoryTalk View for human-machine interface, HMI. This integration allows streamlined project development collaboration between different software components. RSLogix 5000 is a powerful and versatile software platform that empowers engineers and programmers to develop complex automation programs for a wide range of industrial applications. Its robust features, flexibility, and seamless integration with Rockwell Automation products make it a popular choice for programming Allen Bradley RSLogix 5000 controllers.
Finally, I will be using RSLogix 5000 to create a new project, add our PLC and I/O modules, and download to the running PLC. We're going to start by launching RSLogix 5000. 5000 is launched. As you can see, again, this is an older version of the software. Your version may be newer, may look a little different, but the functionality is about the same. We're going to start by creating a new project. Press this button up here in the top left-hand corner, New. We're going to go ahead and select our controller. We'll verify that through links that we have the 1756L63. Look at the properties. Revision 20.018. We're going to select L1756, L63. Revision 20. We will name our project. We do in fact have a 10-slot chassis. We can select different slot arrangements if we desire. We'll stay with the 10. Our processor is in slot 0. The project will be created in the default folder of RSLogix 5000 projects, and we have no security authority selected. We'll proceed by pressing OK. Now that our project has been created, we have several folders over here on the left-hand side. We have our tags, which contain all of our tags and memory definitions. We have our programs, which will contain all of our logic routines, and various other folders that we'll get into within the next session. Right now, we'll concentrate on just adding our I/O modules and performing a download to the processor. Here, down in I/O configuration, we can see we have our 10-slot chassis with slot 0 being occupied by the PLC processor. We'll go ahead and start adding our first I/O module. So go ahead and right-click on the backplane and click on New Module. We can confirm in RSLinx that our next module is the 1756 ENBT Network Bridge module. If we want to do properties on this module, go to Device Properties, and you can see it's revision 3.009. So go ahead and search ENBT, create. Go ahead and give this a module name. Well, let's go ahead and call it Network Module. We'll assign it the same IP address here as what was already assigned on the module. It is indeed in slot 1, and we'll roll this back to revision 3.009. Our electronic keying will be set to compatible module. This means that any like module that is compatible, when placed in that slot, will communicate with the PLC processor. Any other type of module, like an input-output module, would be denied communication to the processor. The keying has to be compatible. You can do exact, which means that exact module with that exact revision must be installed, or you can do disable keying altogether, which means that any module installed in that slot would try to communicate. We'll stay with compatible module. We'll keep rack connection and time sync connection set to none. Press OK. Press yes. Now essentially this is all that we have to do to set up this particular module. There are other tabs in here for diagnostics and advanced configuration, but for now we're just going to click OK. For our next module, you can see we have a 1756 IB16 with a revision of 2.005. Here's 1756 IB16. Create. Go ahead and change the revision to 2.005. Again, we'll keep compatible module. We'll keep the connection type as data, input type as data. Okay. Yes. It is indeed in slot 2. Go ahead and give this module a name. Now, if you desire, you can give this module a description. There is also more configuration options here, but for now, we're just going to click OK. Now, our next module is the same module, but if we look at the device properties, it does have a different revision, 3.002. We'll select the same module, hit Create. .002. Everything else is the same. Okay, slot 3. Okay. Our final module is a 1756 OB16E. The 3.002. Hit Create. 3.002. Compatible module. Everything else, default settings. And then everything else can be default settings as well. Press OK. Now we're done with this module selection window. Press close. We have all of our modules here defined within the I/O configuration. Now we are ready to do a download. So up here in path, select a none. This little button here, new active, is the same button essentially that we have had on RSLinx. We already have our device driver connection path set up. AB ETH-1. Go ahead and drill down. Find our network module. Drill down. Find our backplane. Drill down. Find our PLC processor. Select our PLC processor. As you can see, when we select our PLC processor, it gives us a bunch of options. If I were to go online right now, since there's no program in the processor, it'll just say you need to upload or download. If I were to upload, I'd be uploading the program that is on the processor up to my workstation. That is done if there's an existing program on the processor that you wish to receive. You can download, which is what we're going to do. This is taking the program that's on my workstation and downloading it to the PLC processor. Here is another way to update firmware, but we've already done that through ControlFLASH. So I'm going to go ahead and select download. It'll just give us a warning that we're downloading offline project onto this controller. Here's the controller type, here's the path, serial number, no security, download. Immediately, our processor controller is okay, our I/O is okay. We are online. The processor currently is in program mode. That could be switched with the key that is on the front of the processor. I went ahead and switched the key in the front of the processor. We are now in remote mode. We can switch logically our processor to run mode. Our processor is now running and executing code, even though we have no code for it to execute. We can check the statuses of our I/O modules by going to controller tags, going to the input module, checking data. We have nothing active. We are now online and ready to start writing code for our new processor. Don't forget to save. In our next presentation, we will be going over adding controller memory, memory types, and basic logic instructions. Thank you.
Upcoming sessions in this series. In our previous session, Session 1, Hardware Introduction and Visual Troubleshooting, we had a quick look at PLC hardware and how to visually troubleshoot using status indicators and trouble lights. In this session, we covered connecting to your PLC and I/O module setup. In the next session, Session 3, we will be configuring a program routine and discussing memory configuration types and allocation. In Session 4, we will be covering basic logic instructions and writing a simple ladder logic program. In Session 5, we will be discussing logic troubleshooting methods. Thank you. On the behalf of Flux Automation Services, LLC, and the Non-Ferrous Founders Society, we want to say thank you for your time and interest in our presentation. Please don't hesitate to reach out to us for any further information. This has concluded the recorded section of this presentation, and now we will conclude with any questions you may have. Thank you.